So I will start talking about Python in batch mode. I covered it briefly Friday, where I talked about what a cluster and a batch system is. And this time I'm going to go and look at some slightly more advanced Python scripts. And can you do things like matplotlib and pandas as batch jobs? And sure, yes, of course you can. What about virtual environments in batch jobs and things like this? So we will look at how you would use a virtual environment in a batch script and how a Python code with pandas and matplotlib can be transformed to run in batch scripts. And there are a couple of examples. So there is these compute allocations, the project storage and things like this. And they are all found in the common section of NAISS project overview here. And you can find them here. So we are using Slurm for batch jobs, both for regular and interactive jobs at all these centers here. And you have to run batch jobs for anything longer, resource intensive or parallel, and GPUs as well. GPUs I will talk about tomorrow. Batch jobs in general is not interactive, so you can't make changes to the job while it's running. And to run a batch job, you need a Slurm submit file. Recap, these are some of the useful commands. Okay. So Friday we looked at the simple Python serial code. There are, of course, many other situations. And for Python, there are code that needs self-installed packages in virtual environments. How do you use those in batch jobs? There are codes that require tweaking before you can run it as a batch job. There's parallel code, GPU codes, and so on. And we'll look at some of these today. The GPU example we'll cover tomorrow. We'll also talk about parallelism tomorrow. So today I will only show the very small batch script example. Pedro will cover parallelism tomorrow. So assume you have a package you have installed yourself in a virtual environment. And I will show you here how this is done. So the batch script is very much like it would be otherwise. So you ask for the resources that you would require, and you load the modules you need. And here it's important that the virtual environment that you have created and installed packages to needs to use the same modules as you are loading here. Because you need to activate your virtual environment inside of your batch script. So load the modules you used when you installed the virtual environment or created it, and then activate it inside of the batch script. So do like you usually do, source and the path to it and the virtual environment. And then you can run your script. And it's the same, of course, at all centers. So that is actually not very difficult. I mean, you do exactly the same as you would as if you're running it on the command line. It's just that you do it inside of the script. So what if you had a parallel code, an MPI code? Well, there is not much difference there either. What matters here is that, of course, your code needs to be parallelizable. And then you need to load the correct modules. And it's very common to need MPI for Pi. And that is a separate module at many places except PDC that has that included in Create Python. But most of the other centers have this MPI for Pi. I believe that also, they also have it here, yes. So it's actually all centers except PDC has MPI for Pi. And of course, you also need to ask for more cores, so more tasks, of course, because you probably want to run it on more than one core, since you have an MPI job. And then depending on system, you use MPI run or srun. At some places you use srun instead. But you either need to use one of those. And this example is available in all of these exercise directories. So remember, this one's here you downloaded, so in the exercises. And you should have updated it for today. So if you didn't, then please go ahead and fetch a new copy of the table, because some new things were added to it since Friday. Mainly. There's also something added for this day, yes. So in exercises, go to day 3, and then go into the system you're on. And in this case, I'm at NSC, Tetralit. And here I have some examples here, as you can see. And if I wanted to look at the MPI one, use manual and open it. And just like before, the programs that we are running are located in the programs directory. So you need to change this path here. Only this one thing here, namely your name. And I have this name here at the Tetralit. So I'm changing that. And nothing else needs to be changed. It's good. So I'm saving it. Control X, and then yes. And I'm saving it as that. And then I'm submitting it. And let's see, it's starting to run. It's still pending. So let's continue while it's doing that. So another situation, aside from virtual environments that you might have, is some codes that will run interactively, but not as a batch job, because remember, you cannot access the batch job while it's running. You can't make changes to it, you can't give input to it, and you also cannot open plots while it's running. So it could be you have something that's querying for input, and you can't have that. You need to change it, or maybe it's creating plots and opens them. Again, you have to change that. And those cases are quite easy to change. You can rewrite so it takes input from a file or data set, or maybe give it arguments when you start the run. That is one way to solve the first. And the second, you need to rewrite so the plots are saved to a file instead of being opened directly. A very simple example of option 1. The serial script, the one that was used to run mmmod.py, if that is to run sum to args pi instead, then you can see it asks for numbers, and that means you can simply write it in this way here, because then you give the 2 arguments to the program in the batch script. And that means you simply gave arguments here. You could also have read in a data set with simply have your program load that with the left arrow or something inside of your script. But of course, you need to change your script so it can load it. So that is reasonably easy, and I believe this example is here as well. I think, yes, yes. Again, change here. That should be the only thing to change. And then I can submit that as well. And in this case, It's still pending. Okay. So what if you have a pandas or matplotlib example or code that you want to run, and it has plots that opens, and it might have. So you can do this to see how it looks by log in with if you're using a terminal, you need to use -I or -X. So I have done that here to Alvis. And then I need to load these modules here on it. I'm going to do that. Very slow, apparently, like this. Okay, and we start Python. And then I have a program like this. As you can see, it's a very simple program that's doing a small plot, small scatter plot. And I'm going to show you what it does. And as Rebecca talked to you about earlier, here I need to set the back end. You need to do that at all the systems except for PVC, where they have, I will probably set it within it. So if you have a program like this and you're working on it interactively, like I'm doing now, then you can see why you won't be able to it opens a figure, and that figure wouldn't be able to be opened if you had a batch job, of course. So you need to change this in a way so that this plot here is not shown on your screen, but instead is saved to a file. And that is actually a very simple thing to do. You simply do plot save fig. And I can do that inside here as well. And it should save it. And then I'm quitting it. And let's see if there is now a plot. It is here, as you can see. So that works. And that is an easy way to change your program. So you simply, in this case, it would just be changing plot.show to plot save fig and the name of your plot. And this one is here also inside of your directory here. So it's called pandas matplotlib batch. And it will do the same thing as I just did. Just save it here, change my name. And now I could run this at the tetralit. And if I do that, then it will do this small Python script, but with the same figure instead. So it will create this myplot.png if it ever starts to run. Okay, now things are happening on tetralit, so that's good. And I will just give it a few moments to finish. It has finished. So there should now be this thought. So see. I forgot to probably. Okay, I will see why it didn't work here at the NSC. Well, which systems are you at? Let's see. There is one who is tetralit. So my idea was that I wanted to have you try and run a couple of these here and see it. Both the one for this sum2 args and also this one here. So this is the solution But you can also just try and make it yourself, write this code, or you can find it inside of the exercises directory. But I would like you to try and run it and see that it actually creates this plot here. And meanwhile, I'll figure out where I forgot to set the backend at NSC. So let's do 10 minutes with that before we continue. So let's take 10 minutes for exercises. And I will stop the recording while we do the exercises. So as I said, the batch script for running this pandas matplot code as a batch job is in the exercises directory for day 3 for each of the systems. There is some problem with the matplotlib module for the one on tetralit, and I will test it with a newer matplotlib, and so if so, write a new text on this material. So one thing that you should remember is that if your code has arguments and you're writing it as a batch script, then you need to change the code so it reads in either arguments or a data set. And if you have a virtual environment where you have installed packages to yourself, then it's fairly easy to make a change to a batch script so it will load it. Just load the same modules you loaded in the virtual environment, and then activate the virtual environment, and then you can use the packages the exact same way as you can use modules otherwise. There is a small example for a parallel batch job that you can find also here among the exercises. It's called npi.sh. Pedro will go through parallelism in more detail tomorrow. And then we talked a little bit about how we can tweak interactive jobs so that they can instead be run as batch jobs. And I think that means we are reasonably on time, and we can continue for the summary and the evaluation, which I think Björn is going to do.